Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode, we will be talking about similarity and congruency. So in the previous episode, we talked about triangles, about what is a triangle, how do you classify a triangle based on sides and angles. So if you haven't checked it out, I recommend checking out that episode. So in this episode, we're going to be talking about the similarity and congruence of triangles. So without any further ado, let's talk about it. So first of all, to understand similarity, because it's important, let me take a small example. So both of these are triangles, right? So both of these have the same shape, but it don't necessarily have the same size. So for example, this one is big and this one is small. So that is kind of similarity in a nutshell. Basically, when two figures have the same shape but not necessarily the size, it is known as similarity. Now on the other hand, when you have two figures with the exact same shape and size, that is congruency. So that is kind of the difference between similarity and congruency. Where in similarity, if two figures have the same shape, it's known as similarity, whereas in congruency, if two figures have the same shape and size, it's known as congruency. But that doesn't mean that similarity is just simple as that, because there are some criteria for that. So let's talk about them. So, any two polygons, if they're in the same shape, well, they have to follow these two criteria to, to see if they are if they are similar or not. And if you don't know what a polygon is basically a shape which is made up of line segments, and they also have edges. So for example, any shape that you can see which has shapes or edges in them. So for example, this is a polygon because, well, it has shapes and edges and it's made up of line segments. On the other hand, a circle, it's not a polygon because there are no sides nor there is any line segments. So that is a polygon. So those two criteria which I mentioned, the first of them is that the corresponding angles should be equal. So for example, imagine these both are triangles, and since, like I said, the corresponding angle should be equal, and this is any polygon. So for example, I'm not talking about triangle, we're talking about squares, rectangles, etc. But we're taking a triangle. So first of all, the corresponding angles must be equal. So for example, let's call them ABC and let's call them PQR. Now imagine the angle A is equals to angle P, angle B is equals to angle Q, and angle C is equals to angle R. So this follows one of the criteria for similarity. So angle A is equals to angle P, angle B is equals to angle Q, angle C is equals to angle R. So this is the first criteria for similarity criteria, where basically both of those figures must have corresponding angles. The next one is both of these figures must also have corresponding sides which are in same ratio or proportion. So for example, let me take another example. So let me take two triangles. So let's take 1, 1, 2, 2, 3, 3. Or let's not write this out. So let us draw two simple triangles. So imagine this is 2 centimeters, this is, or let's say this is 1 centimeter, 2 centimeters and 3 centimeters. This one is 3 centimeters, 6 centimeters and 9 centimeters. So like I said, when the second criteria for similarity criteria is that both of the corresponding sides must either be in the same ratio or proportion. So if you can see here, the proportion that triangle, let's call it ABC, is 1:2:3. When this one is in the proportion of 3:6:9. So you can see that they're kind of in the same proportion, because 1:2:3, 3:6:9, or 1/2, when you're doing them like this, and you cancel them, you get 1/3, 1/3, 1/3. So this is just an example, but basically you can understand that all of the ratios are nearly 1:3. So when these two criteria are followed, which is like I said, the first one is corresponding angles and the second one is corresponding sides, which are equal in ratio proportion, that is when similar criteria happens. Now, like I said, these similar criteria happen in a polygon. Now, triangle is a polygon and there are other polygons as well. So, what is a way to specifically find the similarity between two triangles? Now, you have other similarity criteria. So, the four main criteria that we use in triangles are SSS, AAA, SAS, AA. So first let's take SSS, or let's call it side. And we will discuss more about this and what they actually mean as we move on. But for now, for better understanding, let us take a simple example. So imagine you have two triangles again. And imagine both of the triangles are similar due to their sides. So for example, 3 centimeters, 3. Okay, so I think it's working. So apparently the camera stopped working for some reason. It happened again. I'll try to look into it and try to solve the problem. But for now, I'll just try to explain you. Okay, so let me just write them again. I just so I just completed the episode and rubbed it, but apparently it just stopped recording. So let me try to write some, and I'll try to end it as much as possible. I'll try to continue it in the next episode. So like I was talking about, SSS is basically side, where basically if two triangles are, if two corresponding triangles and are there, and in the corresponding triangles, if the corresponding sides are in the same ratio proportion, then the corresponding angles will also be equal, making them similar triangles. So for example, if the sides are equal in both of these triangles, then the corresponding angles will also be equal. In the same way, if the corresponding angles are equal, then the corresponding sides will also be equal in the same ratio or proportion, and that will make them similar triangles. So for example, if they have same angles, if they have same angles, then it'll either be 3, 3, 3, 6, 6, 6, or just 3, 3, 3. It'll kind of work in the similar way. Next you have SAS, which is basically side angle side, where basically when you have two triangles and two of the corresponding sides are in the same ratio and proportion and one corresponding angle is equal, it is similar triangle. So for example, if you have two sides and one angle is equal in both of those triangles, then again it's a similar triangle. Same with AA is basically when two angles are equal. So yeah, that is basically similar criteria. This is the basic of it. We still have to go in depth in it. We have to talk about themes, theory, etc. And we'll probably do that in the next episode, and it will get a lot more complicated. So yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.